energy sources. In these energy sources, nuclear energy is the ability to do work, and it is different forms. Different forms. Hello. Okay. Am I audible? Okay, right. Energy is the different form. In this nuclear energy, energy is the energy released from the atomic nucleus during nucleus reactions, and the most widely used process for electricity generation. Yesterday class we discussed about nuclear energy is a small part. What is the nuclear energy and how it produced? Okay. In this session, what is the nuclear energy sources? Nuclear energy is the energy released from the atomic molecules during nuclear reaction. The most widely used process for electricity generation is nuclear fission. Okay, I will share some PPTs. Wait a minute. Uh, where the nucleus of heavy atoms commonly. Okay, right. Introduction to nuclear energy. First, high energy density source. What is the high energy density source? Where the nucleus of heavy atom, commonly uranium 235 or plutonium 239, is the split into smaller nuclei. This process releases a large amount of heat, which is used to produce steam that drives turbines and generates electricity. Okay. Uh, in this high energy density sources, what is the energy density sources? Uh, One of the source is the meaning of energy density. What is the meaning of sources? Energy density. Energy density refers to the amount of energy stored in given mass of fuel. Nuclear fuels have extremely high energy density compared to conventional fossil fuels. Okay. For example, 1 kg of uranium 235 can produce energy equivalent to about 3 million kg of coal or about 2 to 3 million liters of oil. This is the power of nuclear energy. Once again, I repeat, 1 kg of uranium 235 can produce energy equivalent to 3 million kg of coal or 2 to 3 million liters of oil. Okay, this means nuclear fuel can generate enormous energy from a very small quantity of materials. Okay, reason for high energy density. Energy in nuclear reactions comes from change in the nucleus, not from chemical bonds. According to Einstein mass energy equivalence. What is the Einstein mass energy equivalence? It is the E is equal to mc square. That means theory of relativity. That is called E is equal to mc square. A small amount of mass is converted into a very large amount of energy. Okay. Implications of high energy density. One is the reduced fuel requirements. In example, less mining, transport, and storage compared to fossil fuels. Second one is the compact power plants. That means nuclear plants require much smaller quantity of fuel. Okay. Third one is the high output reliability. That is the reactors can operate continuously for 12 to 24 months before refueling. Okay. Second one is the low greenhouse gas emission. What is the low greenhouse gas emission? What is the emission profile? Nuclear power plant produces electricity without combustion. It's meaning no direct emission of carbon dioxide, sulfur dioxide, nitrogen oxides. Okay. Life cycle emissions. Although nuclear plants themselves emit almost no greenhouse gases during operation, some emissions occur during uranium mining, fuel processing, plant construction, okay, decomposing. Okay. However, life cycle emissions are very low compared to fossil fuels. For example, coal emission is 800 to 1000 kilowatts per hour energy sources. Oil energy sources is 600 to 800 kilowatt per hour, and natural gas is 400 to 500 kilowatt per. Solar PV is called 20 to 50 only. Wind is 20 to 10 only. Nuclear is just 10 to 15 only. 10 to 15 emissions kilowatt per hour. Okay. What is the environmental benefits? Helps reduce to global warming, supports climate change mitigation, and provides base load power without carbon emissions. Okay. Alternative to third one is the alternative to fossil fuels. What is the fossil fuels? A need for alternative. Fossil fuels are finite resources, causes air pollution, contribute heavily to climate change, create energy security issues. Nuclear energy offers a stable and long-term energy solution. Some advantages of over fossil fuels is low carbon footprint and reliable baseload electricity. High capacity factor is there. Nuclear plants typically operated at 80 to 90% capacity. Fourth one is the energy security. Uh, energy energy security. In this, nuclear energy is used to uh, as a primary electricity source in several countries to replace coal and gas plants. Okay, as a complement to renewable energy sources like wind and solar, it provides continuous power when renewables are intermittent, stability to the electrical grid. Okay. Some global importance of nuclear energy is provides about 10% of the world's electricity. Major nuclear power producers United States, France, China, Russia, and South Korea. Many countries are extended the life of existing reactors, developing advanced and small modular reactors. Okay. Uh, Coming to the second side, energy and development. What is the energy and development? Energy is a fundamental driver of economic growth, social progress, and technological advancement. The level of energy consumption in a country is closely linked to its stage of development. Access to reliable and affordable energy enable industrial production, transportation, agriculture, healthcare, education, and communication systems. Okay. In general, energy use increase as a country develop, and energy security becomes a critical component of national stability and economic planning. Okay. What first one is the energy use increase with development. Relation first one is in this relationship between energy and economic growth. Economic development requires industrial production and infrastructure expansion. Some transportation systems are there, urbanization, technological advancement. All of these activities depend heavily on energy availability. As countries developed, industrial output increases and household electricity consumption rises, and demand for transportation fuel grows. Energy intensive technological become common. This leads to direct correlation between energy consumption and GDP. Energy GDP correlation. What is the energy and GDP correlation? Developed economics generally how high per capita energy consumption. I repeat, development economies generally show high per capita energy consumption. Developing economics have lower energy use per capita but rapid growth rates. Okay. As GDP increases, energy demand typically rises. Some observations are early stages of development, like rapid increase in energy demand, shift from traditional fuels like wood and biomass to commercial energy like coal, oil, electricity. Middle income stages, industrialization increases energy intensity. Advanced stages, energy demand stabilizes, greater efficiency and cleaner technologies are adapted. Okay. Energy energy intensity. What is the energy intensity? Energy intensity refers to high energy intensity efficient energy uses. Low energy intensity is called efficient advanced economy. Developed countries often use more total energy but have lower energy intensity due to different technologies. Okay. Second one is the industrial nation consume more energy. Okay, industrial nations consume more energy. What is the industrial consumes more energy? Characteristics of industrial nations. Industrialized countries have advanced manufacturing sectors, possess extensive in transportation networks, use modern technologies, and maintain high living standards. These factors lead to higher per capita energy consumption and reason for high energy consumption. First one is the industrial production. First one is the steel, cement, chemicals, and machinery require large energy inputs. Second is the transportation system. Cars and trains, ships and aircrafts consume significant fuel. Third one is the urban lifestyles like heating, cooling, lighting, and electronic devices increase electricity demand. Okay, technological infrastructure. What is the technology? For example, data centers, telecommunications, and automation. Okay. Third one is the global disparities in energy consumption. What is the development condition? High per capita energy usage, and example United States, Canada, Germany, Japan. Developing countries are lower per capita consumption. For example, India, many African nations is there. What is the implications? Their implications are unequal energy access and development gaps between nations, increased global demand for energy sources. Third one is the energy security is essential. uh, Energy security refers to the continuous availability of energy at affordable prices without major dispersion. In it involves reliable supply, stable prices, sustainable sources, and protection against geopolitical and economical shocks. Okay, importance of energy security, economic stability. In this industries depend on uninterrupted energy supply. National security is military and strategic systems require reliability energy. Another one is social welfare. Energy is essential for healthcare, education, and daily life. Another one is political stability. Like energy storage can lead to unrest. Factors affecting energy security. One is the dependence on energy imports, geopolitical conflicts, and price volatility, and infrastructure limitations. Okay. Uh, Strategies to improve energy security. What is that strategies? One is the diversification of energy sources, domestic energy production, and renewable energy expansion, energy efficiency measures, strategic reserves. Okay. Fourth, some energy and development and sustainabilities are there. In this, first one is that the energy trilemma, energy policy must balance three goals is there. Energy security is there, economic development is there, and environmental sustainability is there. This is often called the energy trilemma. Okay, a role of sustainable energy. Renewable energy reduce depends on fossil fuels, improves energy security, reduces environmental impacts, and developing countries can uh, sorry develop can leapfrog directly to clean energy technologies and avoid heavy dependence on fossil fuels. Okay. Uh, some developing countries in may developing nations are large population lack access to electricity. Rural areas depend on traditional fuels. Energy demand is growing rapidly due to urbanization, industrialization, and rising incomes. Okay, challenges include in infrastructure limitations, financial constraints, energy provider, and solutions is decentralized renewable energy system, rural electrification programs, and energy efficient technologies is there. Okay, coming to the third slide and nuclear energy production. In this nuclear energy production, nuclear energy produced through reaction involving the atomic nucleus, unlike chemical reactions, which involves the rearrangement of electrons. Nuclear reactions involve changes in the structure of the nucleus, releasing enormous amounts of energy. There are two main processes for nuclear energy production. Is there nuclear fission and nuclear fusion? Okay, nuclear fission is the process in which the nucleus of heavy atom slipped into two or more smaller nuclei, along with the release of a large amount of energy, nutrients and gamma radiations. The most commonly used fissile materials are uranium-235 and plutonium-239. I repeated, uranium-235 and plutonium-239 uses in nuclear fission. Okay, basic principles are when a slow moving neutron strikes uranium-235 nucleus, the nucleus become unstable. It slipped into smaller nuclei. Energy is released as heat. Additional nutrients are emitted. Okay, these emitted nutrients can trigger further fusion reaction, leading to chain reaction. Okay, a chain reaction. What is the chain? A chain reaction occurs when neutrons released from one fusion event causes additional fusion events. Types of chain reactions are controlled chain reaction and uncontrolled chain reactions. In controlled chain reactions are occurs in nuclear reactors and used for electricity generation. In uncontrolled chain reactions occurs in nuclear weapons, leads to an explosive release of energy. Okay, components of a fission reactor. First one is the fuel, uranium or plutonium. Second one is the moderator, slow down neutrons. An example, water, heavy water, and graphite. Control rods absorb excess neutrons and made up of boron or cadmium. Fourth one is the coolant, transfer heat from the reactor core. Okay. Fifth one is the contaminated structure, prevents radiation leakages. Energy output. Fission of one uranium-235 atom release about 200 megawatt of energy. Okay, this is millions of times more energy than a typical chemical reaction. Okay, what is the advantages of nuclear fission? Very high energy output, low greenhouse gas emission, reliable baseload power, and small fuel requirements. Limitations of nuclear fissions are radioactive waste generation, risk of accidents, and high initial construction cost and long-term waste management issues. Second one, the nuclear fusion. Nuclear fission means nuclear fission is the process in which two light atomic nuclei combine to form a heavier nucleus, releasing a large amount of energy. Fusion is the process that powers the sun, other stars. Basic principles of fusion is fusion typically involves isotopes of hydrogen, for example, deuterium and tritium. Okay, when this nucleus fusion, the reaction releases a helium nucleus, a neutron, a large amount of energy. Okay, conditions required for fusion. Fusion requires is extremely high temperature. Around extremely high temperature means around 100 million degrees centigrade is there, high pressure is there, and sufficient confinement time. Okay, these conditions allow nuclei to overcome electrostatic repulsion is there. Methods of fusion confinement is magnetic confinement, uses strong magnetic fields, and example, uh, Tokamak reactions and interior confinement is uses laser to compress fuel pellets. Okay. Advantages of nuclear fission. What is the advantages of nuclear fission? Virtually unlimited fuel supply, and deuterium is the abundant in seawater. no long-lived radioactive waste, and no risk of runaway chain reactions. A very low greenhouse gas emission is there. Some limitations is there. Extremely high temperature required and technological challenges in contaminated. Very high research and development cost is there. Not yet commercially available. Okay. Uh, Coming to the next slide, nuclear fission. In this, nuclear fission is the process in which very splits into more lights nucleus accommodated by the release of a large amount of energy, free nutrients, and gamma radiation is there. For example, discuss about uranium 235. The most commonly used fissile material in nuclear reactors is uranium 235. uh, Fissile materials are a fissile material is a substances capable of sustaining a nuclear chain reaction when bombarded by slow neutrons. Common fissile materials are uranium 235, plutonium 239, and uranium 233. Fission reactions of uranium 235 is the when a slow neutron is observed by a uranium 235 nucleus, the nucleus becomes unstable. It forms an existed state. It means uranium 236. The nucleus slips into two smaller nuclei. Energy and additional nutrients are released. Okay. The two fissions fragments are 2 to 3 neutrons, about 200 megawatts of energy for fusion event. Okay, release of energy and neutrons. Sources of energy. What is the source of energy? The energy released in fusion comes from the difference in mass between the original nucleus and the final production. This mass difference is converted into energy according to E is equal to mc square. It means theory of relativity. Even a tiny loss of mass result in an enormous amount of energy. Okay, form of energy released. The energy from fission appears as kinetic energy of fission fragments and kinetic energy of nutrients uh, and gamma radiation and heat energy in the reactor core. Okay, the heat is used to produce a steam, drives turbines, and generate electricity. Emission of neutrons. Each fission event releases 2 to 3 neutrons. The neutrons can trigger further fission reactions, lead to chain reaction. What is the chain reaction in nuclear fission? The concept of chain reaction. A chain reaction occurs when neutrons released from one fission event cause further fission events. Type subcritical reaction, chain reaction dies out, and critical reactions are reaction is self-sustaining, used in nuclear reactors. Uh, Susceptible reactions are rapid control reaction, occurs in nuclear weapons. A critical mass is there. Critical mass is the minimum amount of fissile material required to sustain a chain reaction. Okay, release energy and neutrons. What is the release energy and neutrons? Energy, electricity generation, nuclear power plants, and never now propulsion, medical isotope production. Release reactions is there. Next one is the chain reaction. Chain reaction means a chain reaction is the self-propagating sequence of nuclear fission events in which neutrons released from one fission reaction trigger further fission reactions in nearby nuclei. This process leads to a continuous release of energy. Chain reactions are the fundamental principles behind nuclear power generation. It means controlled chain reaction. Nuclear weapons uncontrolled chain reaction is there. Basic principle of chain reaction are when a fissile nucleus such as uranium-235 absorbs a neutron, the nucleus becomes unstable. It slips into two smaller nuclei. 2 to 3 neutrons are released. A large amount of energy is produced. These emitted neutrons can strike other uranium-235 nuclei, causes additional fusion events, and continue the process repeatably. The sequence from a chain reaction is a self-sustained reaction. What is the self-sustained reactions? The self-sustained chain reactions occurs when the number of neutrons produced in each generation is sufficient to maintain the reaction at constant rate. Okay, for chain reaction to be self-sustaining, at least one neutron from each fusion event must cause another fusion. The reaction continues without external neutron sources. Okay, uh, controlled chain reaction in reactors. Need for control. What is the need for control? In nuclear power plant, the chain reaction must produce energy at a constant and safe rate. Avoid overheating or meltdown. Okay, this is achieved through careful control of nutrient population. Methods of control. First one is the control rods made of nutrients absorbing materials such as bore, cadmium, and hafnium inserted into or withdraw from the reactor core. Functions are inserted deeper, observe more nutrients, slow reaction. Withdrawn means allow more reaction to increase reaction rate. Okay. Second one is the moderate. A moderator slows down fast nutrients, increasing the probability of fission. Common moderates are light water, and heavy water and graphite. Okay. Third one is the coolant is there, removes heat from the reactor core, prevents overheating. For example, water and liquid sodium and gas. Okay. Critical mass geometry is there. Some critical mass is the minimum amount of fissile materials required to sustain a chain reaction. It is the density of fuel and shape of material, presence of neutron reflectors, and purity of fissile material is there. Okay. Coming to the next slide, energy from fusion. Energy from fission is small fuel to large energy, and 1 gram uranium is equal to several tons of coal. What is the mean of energy from? Nuclear fission is the one of the most energy dense process known to humanity. It involves the splitting of heavy atomic nucleus such as uranium 235 into smaller nuclei. This process releases a tremendous amount of energy far greater than that produced by chemical reactions like the burning of coal, oil, or gas. Um, a very small amount of nuclear fuel can produce an enormous amount of energy. For example, 1 gram of uranium can produce energy equivalent to several tons of coal. Okay. Why small amounts of fuel produce large energy? It means mass is equal to energy conservation. The energy released in nuclear fission comes from the uh, conversion of mass into energy. According to Einstein equation, E is equal to mc square, where E means energy released, M means mass converted into energy, C means speed of light. It is equal to 3 into 10 to the power of 8 meter per second. Okay. Even a tiny amount of mass lost during fission result in a very large energy output uh, uh, because at the speed of light squared in as an enormous number. Okay. Energy released per fission event. Each fission of uranium-235 atom releases approximately 2000 million electronic volts of energy. Sorry, 200 million electron volts. MVE, 200 MeV. MeV means million electron volts. Million electron volts. This millions of times greater than the energy released by a single chemical reaction. Energy comparison uranium versus coal. 1 gram uranium is equal to several tons of energy. What is the comparison? Quantity of comparison. Quantitative comparison. Approximate equivalence is equal 1 gram of uranium 235 produces energy equal to 2 to 3 tons of coal. 1 kg of uranium 235 produces energy is equal to 2 to 3 million kg of coal. Okay, this demonstrates the extremely high energy density of nuclear fuel. Reason for the differences are chemical reactions. In coal, energy comes from rearrangement of electrons, and only a small amount of energy is released per reaction. Nuclear reactions means fission. In this, energy comes from changes in nucleus. A portion of atomic mass is converted into energy, result in millions of times more energy per unit mass. Okay. Uh, Practical implication of high energy yield is called a reduced fuel requirements are nuclear plants require very small quantities of fuel. A reactor can operate for 12 to 24 months without refilling. A lower transportation and storage needs to less fuel transport compared to coal plants and reduced handling and logistic costs is there. High power output. Nuclear reactors can generate large amount of electricity continuously and stable baseload power. What is the efficiency of nuclear power plants? Although nuclear fuel has extremely high energy density, actual electricity production depends on reactor efficiency and thermal to electric conversion efficiency and cooling system. Typical nuclear plants efficiency is around 30 to 35% of similar to coal plants, and however the fuel energy content is vastly greater. Okay, environmental implications is there. Some advantages are the low greenhouse gas emission, reduce the fuel mining compared to coal, and less air pollution is there. But some challenges also is there. Challenges are radioactive waste management, high initial construction cost, and safety concerns is there. Okay, coming to the next slide. uh, Nuclear fusion. What is the nuclear fusion? Nuclear fusion is the process in which two light atomic nuclei combine to from a heavier nucleus, releasing a large amount of energy. This process is the primary energy source of stars, including the sun also. Okay, fusion reactions involves isotopes of light elements, especially hydrogen, because their small nuclei can combine under extremely high temperature and pressure. Okay, basic principle of fusion. In nuclear fusion, two light nuclei approach each other very overcome the electrostatic repulsive forces between their positively charged protons. The nuclear merge to form a heavier nucleus. A small amount of mass is converted into energy. The energy released follows Einstein's equation E is equal mc square also. Example deuterium and tritium fusion. The most commonly studied fusion reaction is between two isotopes of hydrogen. One is the deuterium, hydrogen with one proton and one neutron. Tritium means hydrogen with one proton and two neutrons. Fusion reactions are H2 plus H3 is equal to 4 helium molecules and 1 neutron plus energy. Helium 4 nucleus and high energy nutrients is there. Large amount of energy is there. Okay. Equal to 17.6 million electron volts per reaction is there. Why fusion produces energy? Energy is released in fusion because the binding energy for nucleus releases when light nuclei combine. The mass of resulting helium nucleus is less than the combined of mass of deuterium and tritium. The missing mass is converted into energy. The process is similar to fission, but occurs at the lighter end of the nuclear mass spectrum is there. Okay. In these conditions required for fission is fission requires extreme conditions are there. High temperature. First one is the high temperature, around 100 to 150 million centigrade, and required to overcome the column and repulsion between nuclei. High pressure is there, forces nuclei closer together, necessary for increasing collision probability. Uh, Confinement time is called nuclei must remain close together long enough for fusion to occur. Describe the Lawson patients. Okay, some internal confinement fusion is the uses powerful laser beams or iron beams, compressed and heats tiny fuel pellets. Fusion occurs during rapid uh, combustion is there. Okay, fusion in the sun. In the sun, hydrogen nuclei fuse two from helium occurs at a temperature of about 15 million degrees centigrade is there. Energy released as light, heat, and solar radiation. The energy sustains life of on Earth. Okay. Uh, Coming to the next slide. Fusion characteristics is there. What is the fusion characteristics? Nuclear fusion is a process in which high atomic nuclei combine to form heavier nuclei, releasing a large amount of energy. Fusion has unique characteristics that distinguish it from other energy sources, especially nuclear fission and fossil fuels. It is considered a promising future energy sources because of its enormous energy potential and environmental benefits. Okay, so occurs at very temperatures. What is the occurs at very temperature? Need for extremely high temperatures. Atomic nuclei are positively charged due to the presence of protons. When two nuclei approach each other, they experience a strong electrostatic repulsive force known as the Coulomb barrier. Okay, to overcome this repulsion, the nuclei must move at very high speeds. They requires extremely high temperatures. Typical fusion temperatures are around 100 to 150 degrees centigrade for deuterium and tritium fusion, much higher than the temperature at the center of the sun is there. Plasma state. At such high temperatures, matter cannot remain in solid, liquid, or gaseous states. Electrons separate from nuclei. The material becomes a plasma. Plasma characteristics are electrically conductive and influenced by magnetic field, extremely hot and energetic. Okay, sources of energy in the sun. What is the source of energy in sun? Fusion in stellar cores. The sun and other stars generate energy through nuclear fusion reaction occurring their core in the sun. Hydrogen nuclei fuse to form helium. Energy is released in the form of light, heat, and radiation. Okay. Future energy sources. What is the future energy sources? Reason for considering fusion is viewed as a future energy sources because of its potential advantages over current energy systems. Okay. One is the abundant fuel supply, high energy output is there, environmental benefit is there. Okay. um, Coming to the next slide. uh, Nuclear power generation. Nuclear power generation is the process of producing electricity using heat released from nuclear fission reactions. The basic principle is similar to conventional thermal power plants, but instead of burning fossil fuels, the heat is generated through controlled nuclear reactions. Okay? The process involves their major stages are heat production from nuclear fission, converts of heat into steam to rotate a turbine, electricity generation using a generator. Uh, First one is the heat from fusion produces steam. Nuclear fission is the reactor core inside a nuclear reactor. Fissile fuel such as uranium 235 or plutonium 239 undergoes fission. Each fission event releases heat energy, neutrons, and radiation. The heat accumulates the reactor core. Role of coolant. A coolant circulates through the reactor core to absorb the heat produced during fission, prevent overheating of the fuel rods, transfer heat to the steam generation system. Common coolants are light water, heavy water, liquid sodium, and carbon dioxide is there. The steam production is there. There are two main approaches. Are direct cycle is there. Water in the reactor core boils directly, and steam producers in the core is sent to the turbine. Indirect cycle is there, and steam rotates the turbine. Second one is the steam rotates the turbine. Working of the turbine is high pressure steam flows into the turbine. The steam strikes the turbine blades. The turbines begin to rotate. The turbines convert in the thermal energy into mechanical energy. Okay. Uh, Generator produces electricity. The turbines is connected to the electric generator. When the turbines rotates, the generators rotate spins inside a magnetic field. This induces an electric current. Mechanical energy is converted into electric energy. Okay. Uh, Next one is the main reactor components is there. Some fuel rods is there, and sorry, uh, fuel rods means it is the uranium 235 plutonium 239 used in rod form. Okay. Nuclear fuel is the material used in nuclear reactor to produce the heat through nuclear fission. The most common fuel are uranium 235 and plutonium 239, uh, which are fissile isotopes capable for sustaining a controlled chain reaction is there. Okay. The in nuclear reactor, fuel is the typical fabricated into rod-shaped assemblies to allows efficient heat transfer and controlled reactions. Type of nuclear fuel. Uranium 235, the uranium occurs naturally in the earth crust, but only a small fraction in is the fissile isotope uranium 35 is there. Natural uranium composition is there. Uranium 235 about 99.3%, and uranium 235 about 0.7% only. Okay, characteristics of uranium 235 is fissile materials undergo fission when struck by slow neutrons releases heat, neutrons, and radiations. Because natural uranium contains little uranium 235, it is often enriched to increase the concentrate to 235 for most power reactors. Okay. Second one is that plutonium 239. Plutonium 239 is a man-made fissile isotope produced inside nuclear reactor. A formation of plutonium 239 is the uranium 238 absorbs a neutron, it becomes uranium 239. Uranium 239 decoys into neptunium 239. Neptunium 239 decays into plutonium 239. Okay. It is fuel in rod form. Used in rod form is fuel is rod form. Nuclear fuel is not used as loose material. Instead, it is shaped into cylindrical pellets and stocked inside metal tubes called fuel rods. Reason for rod form. Reason. What is the reasons of rod form? One is the efficient heat transfer, better control of the fission reaction, structural strength under high temperature and radiation, and easier handling and replacement. Okay. A structure of fuel rod. What is the structure of fuel rod? A typical fuel rod consists of fuel pellets made of uranium dioxide or mixed dioxide and cylindrical in shape. A cladding outer metal tube is usually made of zirconium alloys and prevents radioactive materials from escaping. Fuel assemble and multiple fuel rods grouped together form the reactor core is there. Okay. Some coming to the next line, moderator slows down nutrients and water, heavy water, and graphite. Moderated nuclear reactors are a moderator is a crucial component of many nuclear reactors. Its primary function is to slow down fast nutrients produces during nuclear fission to that they can effectively causes further fissions reactions. Okay, most fissile materials such as uranium 235 are more likely to undergo fission when struck by slow moving nutrients rather the fast nutrients. Therefore a moderate is essential for sustaining a controlled chain reaction is there. Okay. First one is the slow down nutrients. What is the slow down nutrients? Each fission event releases 2 to 3 fast neutrons. These neutrons travel at very high speed. Faster neutrons are released effective in causing further fusion in uranium 235. The moderator means collides with fast neutrons, reduces their speed through the elastic scattering and converts them into thermal nutrients. The process is called neutron moderation. Importance of thermal neutrons are move at lower speed and have a higher probability of causing fission is uranium 235 help maintain self-sustain chain reaction is there. uh, some water heavy water is there. Water containing deuterium instead of normal hydrogen used in present heavily water reactor. Advantages of very low neutron absorption. Can use natural uranium is fuel efficient moderation is there. One is the graphite is there. Graphite means sodium of carbon used in gas cooled reaction. Some early reactor design is there. Advantages are good nutrient moderator, right? The high temperature resistant is there. Limitations are large reactor size required and risk of oxidation at high temperatures. Okay. Um, Coming to the next slide, control rods. What is the control rods of? Control rods are essential safety and operational components of a nuclear reactors. Their primary function is to observe excess neutrons and thereby controls the rate of the nuclear chain reactions. Without control rods, the number of neutrons in reactor core cold increased uncontrollable, leading to overheating and potential reactor damage is there. First one is the mode of cadmium of boron. Okay. Controllers are made from materials that have a high neutron absorb across section. The most commonly used materials are cadmium and boron. In this cadmium, excellent neutron absorber are used in early reactor begins and effective in controlling thermal neutrons is there. Boron is the widely used in modern reactors, often used in the form of boron carbide and high neutron absorption efficiency, a good mechanical and thermal stability is there. Other materials sometimes used to hafnium, silver to indium, and cadmium alloys. Okay, some observing absorbs excess nutrients during nuclear fission. Each fission event releases 2 to 3 neutrons, and it of all neutrons causes further fission. The reaction becomes supercritical, and controllers are observed some of these neutrons reduce the number of available of further fission. Maintain a stable and controlled chain reaction is there. Controlling the chain reaction. What is the controlling the Third one is the control the chain reaction. The position of controllers determine the reactor's power level, rod position and effective fully inserted and partially inserted and withdrawn. Okay, a role in reactor of evaporations is there. Coolant. Coolant means a coolant is a fluid used in a nuclear reactor to remove heat generated in the reactor core during nuclear fission. The heat produces in the fuel rods must be continuously carried away to prevent overheating of the fuel, maintain safe reactor operation, and transfer thermal energy of steam production. The coolant is a key component of the heat transfer system in a nuclear power plant. Okay, removes heat from reactor. Heat removal from reactor core during nuclear fission, the large amount of heat are released. The heat is concentrated in the fuel rods. The coolant flows through or around the fuel rods, absorbs the heat and carried the heat to a steam generator turbine system is there. Okay. Water means most commonly used coolant used in presses, water reactors and boiling water reactors is there. Some advantages is there. Okay. CO2 used in gas cooled reactors. Advantages are chemically stable at high temperatures and low nutrient absorption, and also higher operations are is there. And liquid sodium is used as one of the coolant. Fast breeder reactors advantages are excellent heat transfer properties and high boiling point, and operates at low pressure is there. Uh, Sorry. And liquid sodium is the one of the used as a coolant. And radiation shielding, one is the thick concentrated lead and protects work and environment is there. Radiation shielding is a critical safety features in the nuclear reactors and other radiations related facility. It involves the uses of dense materials such as thick concentrate or lead to observe and block harmful radiation. The primary purpose of radiation shielding to protect workers and prevent radiation exposure, safeguard the surrounding equipment is there. Okay. Uh, Radioactive waste. What is the radioactive waste? Radioactive waste is the material that becomes a radioactive as a result of nuclear reactor operations and other nuclear activity. It contains unstable isotopes that emit radiation that must be handled, stored, and disposed of carefully to protect human health and environmental is there. Uh, Produce of sources of radioactive waste in nuclear reactors. What is the sources? Spent nuclear fuel and activated reactor components and coolant and operational materials. Okay, high level waste is that waste with high radioactive and heat generation mainly consists of spent nuclear fuel or waste form of fuel. Okay. Low level waste is the waste with low level of radioactive and does not require heavy shielding is there. Okay. Next one is the half life. Half life is the time required for half of the radioactive atoms in a sample to decoy into another element or more stable form. It is a fundamental concept in nuclear physics and radioactive waste management. Half-life determines how long a radioactive substance remains hazardous. The persistence of radiation in the environment is the radioactive decay process is there. Radioactive substance contain unstable nuclei. This nuclei is the spontaneously transform into more stable nuclei, emit radiation to into the process. The types of radioactive decay is the alpha decay. and beta decay and gamma decay. Okay, a concept of half-life is the radioactive decay follows the explosion loss. Okay, uh, commercial nuclear power. A commercial nuclear power refers to the generation of electricity from nuclear reactors operated a galvanic large-scale energy production. Unlike research or merit or military reaction, commercial nuclear power plants are designed to supply electricity to national power grids for public and industrial use. Nuclear power is an important component of the global energy mix because it provides reliable baseload electricity, produces low greenhouse gas emission, use fuel very high energy is there. Uh, first plant First commercial nuclear power plant is Calder Hall in 1957. The world's first commercial nuclear power station was Calder Hall, which began operation in 1957 in the United Kingdom. Location is the England, and reactor type is Magnus gas and cooled reactor. Fuel in this natural uranium is the fuel, and graphite is the moderator, and coolant are carbon dioxide gas is the coolant. Significance the first nuclear plant to supply electricity to public power grid and marked the beginning of uh, civilian nuclear energy farms is there. Growth of commercial nuclear power plant expansion in the mid 20th century. After Calder Hall, um, they many used in many countries. Many countries started nuclear power programs. A major expansion occurred during in the 1960s to 1980, rising of electricity demand and oil crisis of the 1970s. Need for energy security. Interested in low carbon energy sources is there. Countries using nuclear power today. Nuclear power is used in many countries across the world. Major nuclear power producers are United States and France, China, Russia, and South Korea, Canada, United Kingdom, India, and Japan. Japan is the partial operation after Fukushima incident. Uh, Share of nuclear power is the nuclear power produces about 10% of global electricity. Okay, some next one is the Indian nuclear program. In the Indian nuclear program is a long-term strategy developed to use nuclear energy for peaceful purpose, especially for electricity generation. It was designed to address India's growing energy demand, limited fossil fuel resources, need for energy security, and commitment to low carbon development. Historic first plant is Tharapur 1969. India's nuclear program was initiated under the leadership of Dr. Homi Bhabha, the father of Indian nuclear program. In 1948, establishment of the Atomic Energy Commission, and 1954, creation of the Department of Atomic Energy and development of research reactor and nuclear infrastructure. In 1969, the India's first commercial nuclear power plant was the Tarapur Atomic Power Station, commenced in 1969 in Maharashtra. Reactor type is the boiling water reactor is there and supplied by United States, and units are Tarapur 1 and Tarapur 2. Each unit approximately 160 megawatt capacity is there. Okay, reactor types used in India is India primarily used two types of reactors and boiling water reactors and pressurized heavy water reactors is there. Major three-stage nuclear power programs are there, and uranium 235 natural uranium reactor type in uh, a pH double R is there. Fast breeder reactors is uranium 239 we used in that. And coming to the next slide, three-stage program is there. The three-stage program in one is the natural uranium reactors, second is the fast breeder reactors, third one is the thorium reactors. In the three-stage reactor power program is a long-term strategy designed to achieve energy dependence by efficient country's nuclear reaction is there. Okay, leave.